In order to understand the features of ZigBee devices, which are the core of the wireless personal area networks these days, we have to go into a little more detail. In this module, we should look at the technical aspects of IEEE 802.15.4, and then we'd look at different topologies which could be realized. An appreciation of these features and understanding how these 15.4 devices form topologies, it would help you to perform the simulations and do requisite network modeling. Let's look at the features first. In terms of the physical and logical channels, there are 16 channels in the ISM band, that is 2.4 gigahertz. There are 10 channels in 915 megahertz, and there's just one channel in 868 megahertz. You may wonder that why so many channels are distributed across this frequency spectrum. It owes to the fact that in most countries, these frequencies are available, but because of certain conditions and preoccupation of frequencies in a certain country, some of these frequency bands might not be available for WPANs. That is why this diversity is essential. Depending upon the interference and the bit error rate, the effective over-the-air data rates of 250 kilobits per second down to 20 kilobits per second are available. Just compare it to Bluetooth, which would offer 1 megabits per second. Data rate of 20 kilobits per second seemingly looks useless, but in reality, for certain industrial and home automation control, this data rate is good enough. The addressing schemes which are provided in WPANs are based on either short 16-bit addressing or 64-bit extended addressing. The reason for providing two different kinds of addressing is to allow flexibility and at the same time ease of processing, because 64-bit addressing essentially means more overhead. In terms of the time slots and the resource allocation in WPANs, both of carrier sense multiple access collision avoidance, which is the contention-based scheme, is offered, as well as the contention-free period-based guaranteed time slots are offered. WPANs allow both unacknowledged and acknowledgement-based data transfer for reliability. In order to provide longer life to these WPAN nodes, there is a feature provided which is called low power consumption through duty cycle management. What happens is, when nodes form a network together, they share their sleeping schedules and only wake up if there is an event. And for most of the time, these nodes end up sleeping, and the overall lifetime of the WPAN can be guaranteed, because as we have discussed earlier, these nodes have batteries which are mostly non-rechargeable. There's also a mechanism called energy detection that allows a node to know if its battery is going to die. So if a battery is becoming weak, the behavior of the node can be changed accordingly. As we shall see in the next slide, a node can have different kinds of behaviors depending upon its computational capability as well as the battery status. And lastly, the link quality indicator determines the overall health of different links which a node keeps with its neighbors. And it can choose to opt for the best link which provides the strongest receiver signal strength indication versus noise. The topology support which is given in IEEE 802.15.4 is star, mesh, and tree. Let's start with star first. Here in star, similar to Bluetooth master-slave configuration, we see that we have a coordinator in the center that manages the nodes within its personal network, and these devices are acting as leaf nodes or as end devices. In Zigbee terminology, the main central node coordinator is called the full function device, and the devices on the leaf or on the edge are called the end devices. Here, the mesh configuration is shown. It is basically a tree configuration with loops. What we see here is the addition of another color node, which is blue here. These blue nodes are actually governed by the coordinator here, and the end devices can be connected to the overall network here either directly with the coordinator or through the routers. The advantage of this is that the overall coverage of the network has now been extended, and as more number of nodes join, they can either join in as routers or as end devices. The obvious need for such incorporation is that when a large area needs to be scanned and sensed, then these nodes must form a topology which is not disconnected. This is the cluster tree, which does not have loops. What we observe here is that the nodes have a child-parent relationship upwards, and each of these clusters are communicating to each other via the coordinator, which is serving as the parent node or as the central entity which manages the overall communication.